In the figure shown, we have a square PQRS and we have a semicircle whose area is given as 11 by 14 meters square. Also, PA is tangent to this semicircle at point B, and we are asked to find the area of right triangle PSA. So first of all, since the area of semicircle is given, we can assume that the radius of this semicircle is small r. So from here we can write pi r square divided by 2, that means area of semicircle is equal to 11 divided by 14. We can cancel this 7 times. So this will give us, in place of pi, we can write 22 divided by 7 times r square is equal to 11 divided by 7. So if we simplify, 7 and 7 gets cancelled, and this will be r square is equal to 11 upon 22, that is 1 by 2. So from here we can write r is equal to 1 upon square root of 2. So the value of r is 1 upon root 2. So this length will also be the radius of this semicircle, 1 upon root 2. Hence the diameter of this semicircle will be equal to 2 times 1 upon root 2, that is 2 upon root 2 or root 2 units. Now this diameter of semicircle is the side of this square PQRS. So we can write PS is equal to root 2 units. Now coming back to what is asked in the question, area of right triangle PSA. So this will be equal to half times this distance SA times the altitude, that is PS. So we just found out the value of PS as root 2. Now our focus will be to find the value of SA. So for that, let us assume this length AR as X. So AB will also be equal to X. Why? Because we know that if this is a circle and from any external point, if two tangents are drawn to the circle, so this is the point of contact, this is another tangent, and this is the point of contact. So these two lengths must be equal. This is the theorem. So we see here A is the external point, AR will be one tangent and AB will be another tangent. Hence, if we are assuming AR as X units, so AB will also be X units. Now let us apply the same theorem to point P. So point P is an exterior point, PQ is tangent, and PB is also tangent to this semicircle. So this length PB will be equal to PQ. What is PQ? PQ is the side of square, which we already found as root 2. So this is root 2. So PB will also be root 2. Now let us focus on this triangle PSA. So let me draw it outside. This is vertex S, this is P, and this is A. What is PS? The length of PS is root 2. What will be PA? So PA will be root 2 plus X. So this will be root 2 X. What will be SA? So if we see here, S to R, this distance is root 2, and from R to A is X. So the remaining distance SA will be root 2 minus X. So let us write down root 2 minus X. In this triangle PSA, we will apply Pythagorean theorem in order to find the value of X. So we can write root 2 plus X whole square equals root 2 minus X whole square plus root 2 square. Now we will use the identity a plus b whole square to expand this. So this will give us 2 plus x square plus 2 root 2x equals, likewise we will use the identity a minus b whole square and we will get 2 plus x square minus 2 root 2x, and finally this will be 2. We can cancel x square from both sides and we can separate the terms with variables on one side. So this will be 4 root 2x equals, also 2 and 2 will get cancelled, only this 2 will remain here, so we can write is equal to 2. So x will be equal to 2 divided by 4 root 2. We can cancel it twice, so 1 upon 2 root 2. So the value of x is 1 upon 2 root 2. So after getting the value of x, we can find the value of SA. SA is root 2 minus x. Here we can write root 2 minus x is 1 upon 2 root 2. We will close the bracket here. Now let me clean the board. So the area of this right triangle PSA can be written as half times root 2 minus 1 upon 2 root 2 times root 2. Now we will multiply root 2 with root 2 and with the other term. So this will be half times root 2 times root 2 is 2 minus this will be half. So half multiplied with 2 minus half is 3 by 2. So this will be 3 by 4 square units. So the area of this triangle PSA is 3 by 4 square units. If you want to get more such videos, do subscribe to my channel. See you in the next video.